not doing it any further. Thank you.
Why is it always me, dude?
Because
I'm trying to finish answering their question.
You're interrupting.
I'm trying to finish answering their question.
Okay, go ahead. Just don't interrupt. Go ahead.
God, either you have a substitute or not. If not, then you're the one that has the conundrum. Either you have a refutation of my position or not. Otherwise, my position stands unrefuted. So this is where we progress to the uniformity of nature when you ask that question.
I got a refutation for you. It's not a god. There's a set of underlying principles and mechanics and properties you don't understand. That could be the alternative. Back up your
Okay,
bag.
so let's address that. So how did you get the laws in the first place?
What's that got to do with the fact that your reputation?
Yeah, you're not engaging. You suppose a substitute.
All right. Where did your gob come from?
He's interrupting me now. So are you going to admonish him?
He's trying to get you to change the topic to how you can understand anything. Like if you have no reason, if you have
Why
no
is
God,
he doing that?
then you can't.
He's interrupting me
anyway.
now. Is someone going to admonish him?
Let's just grant him.
Hey, moderation. Everyone needs to come. Moderation.
I'm still in the middle of speaking.
Okay.
Let's just grant him his God.
Do you not know what moderation means?
Yeah.
That means you don't get to just keep talking through me and saying I was talking. Everyone needs to calm down, dude. Okay. There is a difference in like accidentally overstepping a little bit or interjecting with quick phrases and then just powering over someone, powering through them and talking through them and demanding that they answer the way that you want them to. Okay. So if everyone can please calm down and try to show what's up, man.
What, man?
It's like insane. Just try to show some respect. If people are all worked up right now, they need to take a deep breath and calm down. Everyone just try to be succinct, specific to the point, respectful, and not interrupt. Please.
I think he anyway left.
No, I'm here.
No, not you. You were just asking. Okay.
Oh, Greg left? Yeah, Greg.
Why does Flatman interrupt though? That cracked me up. Anyway, yeah, go on.
No, I was just saying Gregory was trying to shift it to like reasoning at all, but he left, so we can move on.
Okay. Well, I do have a question for Witsit though for the medium argument, right? Because I think I could be wrong on this, but earlier you said that basically the medium is what decides, whether something goes up or down, right? Or did I kind of, like simplify that?
Yeah, you simplified it. It's the interaction between the object and the medium. Okay. So pressure mediation relative to the relationship between the object and the medium. I'll say it again. Pressure mediation relative to the relationship between the object and the medium.
Okay.
Pressure mediation relative to the relationship between the object and the medium.
Okay, well, yeah, I guess the pressure part might be important because what I was going to ask was because I know in a vacuum chamber, or not even a vacuum chamber, just let's say you have like a chamber, right? It's not vacuumed out yet, right? But if you have like air in there, right, and you have a helium balloon, right? The helium balloon is obviously gonna be like floating in that, going upwards, right? But if you take the air out of that, right, now there's less air, so it's less medium, and yet it drops. So I guess maybe the pressure part is maybe important in all that.
I mean, I do get that, like the interaction with the medium. If you first claim down is the floor and the most dense stuff goes down, however, why? And then, of course, you have a medium, and then you have something that can float, can go up, can go down, or can distribute equally because of same weight, like gas, or like nitrogen and oxygen is mostly distributing equally. And if you have water, you have an apple that floats on the water. I do get that point, but that whole density and buoyancy still does not explain to me the direction.
Also, why do things weigh less at higher elevations? Like slightly less, but they do weigh less.
Yeah, that's okay. and that's what I want. That's a point I wanted to address. Sorry, can I just answer to that one thing before we to go?
Yeah.
That was the point what I half an hour or 2 hours ago. I said, like, if you weigh a weight on, let's say, sea level with the surrounding air, and then you remove the air, like you have it in a vacuum chamber, but the vacuum chamber is filled with air, and you have your scale in the vacuum chamber, and you have your weight in the vacuum chamber, then it weighs a specific amount. And then you remove the air, that scale will show a little bit more mass because the object seems to get heavier because the surrounding air causes less buoyancy on that object. But if you elevate now the weight into an airplane or something like this, you see that it gets less heavy. So you see there is a directly correlation between the height, and there is a correlation between, like, the medium that it's in. So the height in an airplane cannot be the situation with less air pressure, because the air pressure in an airplane is nearly similar to the ground level. On a mountain, it's something different, maybe.
Okay.
Mountain's better because airplane has turbulence.
Yeah. So we have an electric field on the Earth, and it has equipotential lines, and we have an increase in potential that's 100 volts per meter as you go up. And because all objects are intrinsically electric, and all mediums are as well, that object is within the electric field on the Earth. And so I would expect there to be a relationship between height and weight, although provably inconsistent and very small.
But if it's the electric field, you could just reverse polarity, or you can make an artificial electric field, and it would reverse it completely. So you could create anti-gravity with it.
You can, yeah. You can make objects float. Yep.
What objects? Like styrofoam balls or a golf ball?
Literally any material. There's not one material.
I have never seen anything levitating except of superconductors or something that is magnetic, that is heavier than a styrofoam ball. Can you give me any kind of videos or something like this?
I'm just gonna say, dude, if you're gonna keep jumping all over me, bro, I'm not gonna have a conversation with you. So you now shifted it to this arbitrary determination of how heavy the object needs to be. Now, of course, that's totally irrelevant in physics because physics scales. So if you establish a principle of physics, it automatically scales. So how heavy the object is doesn't matter. If I drop a golf ball and a ping pong ball in water, the golf ball sinks. There's a principle of density. We've established a principle of physics. I don't now need to have the world's biggest golf ball and drop it in the ocean, or density isn't true or something. That's not how physics works. So you're saying you switched it from, you sounded like you were just going to say something that has magnetic properties, then all of a sudden you said, or heavier than styrofoam. So the heaviness doesn't matter. And so, yeah, literally any material, whether it's wood, now styrofoam is good, styrofoam, wood, rubber, glass, iron filings, you name it, right? Any insulator even that you can think of, you can make them all floats. So therefore, if you had bigger objects of the same material, you would just need a proportionate increase in the actual electric variable that made it float. Because this is how physics works.
Do you think we haven't done experiments to control for these variables?
What? Yeah, every time we do the experiments, we provably can manipulate the weight of an object based on the electric field in its surrounding area. So
lead ball, you can manipulate a lead ball with electricity?
Yeah.
Can you show any kind of videos or something of that?
Okay, look, I'm going to repeat this again. Let's talk about it really simply. Do we agree that if we have a really small light object, I can use just an everyday Van de Graaff generator to make it levitate?
Yeah, like I said, styrofoam ball.
It doesn't have to be styrofoam. It can be wood.
Something super light. Something super
Oh.
light can be levitated with electrostatics. I have
Okay,
seen
now
that
we're not
often.
okay,
I have
and
made
let's not
that.
talk about the weight. So let's talk about the material. Do you agree that it doesn't matter what material it is?
I think as long as it's not conductive, as long as it's an isolator, yes. Because if it's conductive, then the electric field will flow through it and it will not be affected by the field.
You can absolutely make any type of material float with electrostatics or with the manipulation of electric field. Now,
I hear
saying
you, but I have never seen it. Can you show it somehow? That's what I'm asking.
Dude, yeah, I've done it myself with many different types of objects. Okay, many different types of material, and I just named them. So I use like hair, iron filings, wood, styrofoam. Okay, now
You ever used lead?
But these are all small
why would
things.
lead be different? Why would lead be different?
Tinfoil.
Why would
Because
lead be different?
it doesn't conduct magnetic fields. So like it wouldn't be affected by electromagnetic currents.
So wait, you're saying that I can't repel lead with an electrostatic force? Okay. So yeah, even lead can have a surface charge. Did you know that?
Did you use lead in your experiment?
No, answer my question. Did you know that lead also
Yeah, of
has a
course.
surface charge? Okay.
You can charge lead because it's sure. But
Right.
I have never seen a heavier object. I mean heavier than something that you would not feel if you have it on your hand, like a hair, styrofoam ball, a micro small one, piece of paper. You don't feel it actually because it's so light. You don't
Doesn't
know if
matter.
it's there or not there. But
Okay.
if you have like a golf ball, do you have a
Alright,
video
well-
or something like this that would be super new, super interesting for me? Do you have a video of a golf ball or something heavy as this is being levitated by electrostatics?
Real quick, Witsit, real quick. It doesn't matter if the thing's super light, like if it has a very little amount of weight, you can change the weight with this. Obviously, if it's not pressing down, right? Am I wrong?
It
Why
seems
does it
so,
matter
but
how much
not
weight
enough.
the thing has? What does
Now
it
you
matter if
interrupted.
can
You asked something. Now you asked
Alright, go
something,
ahead.
and you interrupted again. So I think the weight makes, electrostatic fields can change measurable the weight of something, but not enough to levitate a heavier object. And still the claim at the moment is that electrostatics is pulling heavy things down, pulling ships down to the earth, but I have never seen something that has a significant weight, like a golf ball. We had potatoes some
You've
hours
said this
ago.
5 times, and every time I go to respond, I'm not able to do it.
Go
And
ahead.
I've already responded
ahead.
to it. Okay. Again, in physics, things scale. This is the worst argument I've ever heard. I don't know how you guys got tricked into all adopting it, but can you please engage with the rebuttal because it is a terrible argument. I gave you the analogy of dropping a ping pong ball and a golf ball in water. The golf ball will sink, but the ping pong ball will float. That's because of density and buoyancy. We
Agreed.
we know that that's a true principle of physics. I do
Can
not.
we
We do not put a little asterisk beside it and say only at this size. And then we go build a
No.
boat that works off density and buoyancy. We say, oh, only at this size. But you need to show me the world's biggest boat, or I don't think it'll keep working. No, we know the principle works, right? So the
build
relationship
something to
is just, buddy, chill. So that's the same with this. We know that an object's weight and the fact that it's going down can be manipulated with electrostatics, with the relationship with the electric field. That means if you were to introduce enough of the electric variable that is doing that to a big object, you can also make it float. The problem with it is that, for example, if I wanted to make you float, I would have to kill you like 1,000 times over. It would be extremely dangerous to do it. Okay. But yes, you can absolutely do it. In fact, we have electrostatic drones. We have many
We?
different, we have all, yes, we have electrostatic generators. We
So,
have
so you
we have all kinds of tech. We have electrostatic drones. We have technology being developed by all kinds of people like MIT and Raytheon that are utilizing electrostatic propulsion. It isn't disputed, right? The only issue at hand is making sure that you can safely utilize the technology based on the actual relationship between its weight and the amount of charge that you
so
have to introduce. So denying this by just, if you think it's a rebuttal to say, well, I haven't seen something this big yet. You know, I need something because what happens if I go show you a golf ball doing it? You'd be like, oh, all you can do is a golf ball? What about something bigger than that? I haven't seen someone do my phone. And if I did it with a phone, then you'd be like, what? I haven't seen someone do it with a car. Why don't we have flying cars yet? But none
Yeah,
of
we
this
should have them
matters.
built.
I'm making the
We should.
point one more time. I'm making the point one more time. The principle has been proven scientifically, indisputably. It automatically scales. That's how physics works. Okay, so you cannot just hand-wave dismiss it by just arbitrarily placing some random weight requirement on it. That isn't a rebuttal.
But I do
so
disagree that
so
everything
hang on.
scales linear. I do disagree. I do agree with the buoyancy and density stuff, and that there it scales linear. But I do disagree with, for example, a lot of stuff that has to do with weight. For example, there is a limit for insects or let's say animals with an exoskeleton in their size, because from some size on, they cannot lift their own weight with an exoskeleton. There is a limit on size of how big an elephant could be or so. And you see that an elephant needs way more like muscles and bones and stuff to lift its own weight compared to an ant that can lift 10, 50 times its own mass because it's super small. So you cannot scale everything linear up. So you cannot say, hey, I can lift a styrofoam ball with a little bit of electrostatics. So it would work for every bigger thing. And I don't ask you to levitate a ship. I just said, is there any proof or video or something of a electrostatic field with this 100 volt? That's not much. 100 volt per meter is really not much. I have seen frogs levitating in a magnetic field. That works, but I have never seen like electrostatics lifting real elements, like
Do you
everyday elements.
genuinely not understand that your point is not a rebuttal?
Like
And
that bit
for
about
it
the
to
elephant in
even
the ant is irrelevant.
that was
for it
like
to
a
even
really bad
inch
rebuttal.
towards for it to yeah, well, it wasn't. For it to even inch towards a rebuttal, you would have to offer specificity as to what changes physically. So actually in terms of the electric properties itself, what changes physically once you introduce more weight? Why would it all
So
of a sudden stop working?
well, you were talking about how like we can predict like buoyancy and all these other things, right? And we had the buoyancy formula for that, and you agree with it, right? What's it?
Yeah, man. Yeah, man. I don't know if you're gonna answer my
Okay.
question or not, though. But I got a phone call now.
So, well, no. The problem is in the buoyancy force, there's an acceleration g, which is the gravity in that formula.
Dude.
So, like, if you're saying we know these things, we know when something will be buoyant. That's because we use the acceleration of gravity in that formula.
Got it. Your metaphysical presuppositions is not necessary for there to be density
We're not talking about density. We're talking about buoyancy right
or
now
buoyancy.
because it's a buoyant force.
MAM nor TGR is a necessary precondition for buoyancy.
Yeah, I mean,
Yeah, the acceleration g is in there.
Neither
You do-
MAM nor TGR is a necessary precondition for buoyancy. I'm not going to just presuppose that with you.
Your God is the necessary being for buoyancy. That's fine with me, but buoyancy's formula still has gravity in it.
That's your doctrine. It's not
No, that's
actually true that you need MAM nor TGR for there to be buoyancy.
Yeah, you don't need stuff pulling down to go up.
Did he have to factor?
Well,
I mean, Cavendish didn't have to factor buoyancy in, right? Did he?
What was
Can I
the-
just respond to the one you don't need stuff to go down to other stuff to go up? I think that's not true because a helium balloon in air goes up because of the air surrounding, because the air goes down. If you have a helium balloon in a container with air and then you drop both, the helium balloon will not stay up. It will float somewhere in that container because you let it fall, as long as you let it fall in a vacuum, and that has been tested. Or you have, for example, a container with some liquids like oil plus water, and then you drop that container. The oil and the water is just mixing each other because you are removing the force pulling down the heavier water and therefore lifting the lighter oil up. So that's just not true.
You didn't do anything. That didn't
It's
even
hard
make
to
no sense.
interrupt when you don't even address what I said. I don't know who you were addressing there. Maybe you were addressing somebody else. Did Cavendish need to factor in buoyancy when he did? Did Cavendish have to factor in buoyancy when he did his Cavendish experiment?
No.
No, because when you're dealing with lead balls, the buoyancy of the air is negligible.
So this gravity thing has nothing to do with buoyancy.
Do you know what negligible means?
Correct.
And I think Cavendish was on a horizontal scale, not vertically. So that's why the
No
buoyancy up, down. Yeah, but the Cavendish experiment turns stuff. It's not lifting or lowering stuff. So it's a horizontal movement, not a vertical movement. So buoyancy and density only causes vertical movements.
If you're on a
Nothing
ball,
goes
you
left
gotta have
and right.
buoyancy both. If you're on a ball, you gotta have buoyancy both ways, son. What are you talking about?
Can someone help me?
Towards your
Someone
horizon
help
is
me
towards
understand.
space.
I'm not talking
why
about
is it
ball
that
or not.
why is it that you guys never answer the question? Like, why do you guys all like condescendingly dismiss the position, but none of you ever engage with it in
I
entirety?
did.
You asked me to show you something heavier. And I said physics scales, provably you can prove it on the smaller scale. The only limitation is actual safety, right? And the ability to like truly get enough like say charge to be able to do it. And then I said, but for that to even inch towards a supposed refutation or rebuttal, you need to at the least provide with specificity why that phenomena would change with weight.
Okay,
Because
back to the electrostatics. I
so
agree with you that you can lift super heavy weights with a super high voltage maybe in a vacuum so that the voltage cannot jump from the plates to the other one and something like this.
well, hang on, real quick. Witsit. The reason why is because if the electricity isn't affecting the objects all uniformly, that means there is something else that is affecting it. That variable is not strong enough to it doesn't control all. There has to be something else. That's
Okay,
why
so
the
no one answered the
electrostatic isn't
question.
enough to explain. I
No
just
one
did.
answered the No,
Oh,
you
you
didn't.
didn't.
So no,
Oh,
you
listen
didn't.
again. Hold on. So instead of doing that, just say the question again, and then.
Okay. Okay. So again, I pointed out that yes, you can manipulate the weight of an object or make it float by manipulating the electric field. And then they said, well, I've only ever seen you do that with. I'm going to only lay this pre-context out again, then I'm just going to start repeating the question. And then I said, they said, well, I've only seen you do that with something like styrofoam or something really light. You know, can you do it with something heavy? As if it's someone's hot mic. Bro.
I got it. Hold on. Who is it?
I think it might have been Regis.
So as if that was a rebuttal, right? And I pointed out that's not a rebuttal because the physics principle remains the same. It automatically scales. So then I said, here's the point. Okay. If you think that's a rebuttal, this is what you have to do at least. Can you explain with specificity why that phenomena would change with weight?
So you're saying if you could do it with something light, why would it change with something heavier?
Yeah, exactly.
That's what was my point earlier. I don't know if I got addressed or not. I had to do something in my house, but
Dude,
if
4
you
years,
can do
nothing
it,
Answer
that
that
was ever
question now.
addressed.
if you can do it with something that weighs a nanogram, why couldn't you do it with something that weighs a gram or an ounce or a pound? If you just added more charge.
You can.
So go ahead and answer the question now. Flat Earth are silly. Flat Earthers are silly. Go ahead and
So,
answer the question now.
I
This is
think
your turn to talk.
he's
See,
still
now
muted,
when
but
it's their turn to
you can
talk, they don't
start.
speak.
Did you guys hear the question or?
Can I say something quickly?
Not
Hold
if it's
on
not
then.
answering the question.
Yeah, just
No, it's to do with the topic. But yeah.
Okay, but hold on. But I know there's a topic going, but we're looking for an answer to this very specific question.
So
Okay,
the
so
answer
Flat
to the
Earthers are silly.
question.
Go ahead and answer.
So the
Yeah,
answer
it was
to
in
the
the source.
question why it does not work on heavier objects. This is still asked.
Yeah. The
No, why
question
Okay.
would
is,
it? Why wouldn't it
Okay.
work?
Yeah, okay.
why
Okay.
wouldn't it work? Yeah.
So because heavier objects or objects with higher mass have a higher gravity causing on it, but so this is scaling upwards, but you cannot charge objects indefinitely with electronic charges. So you
How do you
can
know that?
charge elements only with a specific amount until either the voltage is flowing away from these elements, so like free electrons flowing away from the element because it's overcharged, so the electrons itself are pulled, and if you charge something with electrons, then the thing itself is pulled with the electrons up. But if it's too heavy, then the electrons itself are pulled away from the object that you try to charge. Therefore, there is a limit how heavy these elements can be. I have not the number in my mind, so don't ask me for that. But I have always only seen very light objects, and if it would be possible, I would definitely bet that if it would be possible to levitate a golf ball just with electrostatics, it would have been done and it would have
What if
been
we could do a
shown.
frog? What if we could do a frog?
Frogs can levitate in a magnetic field. That works, I know that. But not in an electric field. That frog would be dead. And
Electric fields are magnetic, and you
no.
need to have temperature. You're not talking about.
Hold on.
No, a magnetic
All right.
field is not an electrostatic field. That's
But wait,
totally different stuff.
pause. You just said it, but it would be dead. So you're literally saying, yeah, you could do it, but it would kill the frog. Like there's a Van de Graaff generator in Oak Ridge in Tennessee that does like 25 million volts.
Did they do
So,
did they do a dead frog?
Does it
No,
levitate every object, or
Why?
are there
Why
limits
would
to
it
it?
levitate, dude?
And
It's gonna
and hang
be.
on, I'm almost done. I'm almost done.
You're almost done. You just
Like
paused 10
even
seconds. Okay, go ahead.
yeah, if you had like a 2 pound lead ball, like or whatever, like does it affect that as much? Like does it affect things equally, despite what it weighs?
Okay, again. So it is not going to all be exactly the same because different materials react to charges differently, right? Okay, and I know you guys think that's some type of big rebuttal, but before we even get to that point, it's
It
yes,
just means that it's one.
if you had enough voltage, you could move anything, literally anything, because the principle of physics doesn't change. And that's why you guys can't articulate with specificity why it supposedly would. You guys just say, "Nuh-uh," or show me something. Dude, you
I
know how
mean,
irresponsible it would be for some type of university or some type of scientific program to try to go levitate a car with
let me
electrical charge?
rephrase.
But we are not
Do you
talking
think
about a car.
do you think it's voltage and electric currents solely that causes things to go up and down, or is there another
No,
variable?
there are multiple variables. It
What
all
are
can be
some of the other
summarized with,
What are some of the other
dude,
variables that
you're
you think
awful
there
to have
are?
a conversation with, man.
I just no because what are some of
No,
the
you're
other
just like
variables?
frantically replying and not letting anyone finish their reply to you.
Yeah. And then I told you that you're terrible to have a conversation with, and you said no. What? Yes. Yes, actually, you are. Like, it's just,
What
please listen to what's being said if you're asking a question. It's super disrespectful to ask a question and not listen. So, dude, there are multiple variables. We've summarized the phenomena with the fact that there is pressure mediation relative to the relationship between the object and the medium. Now, that entails many things. For example, all the properties of said object and all the properties of said medium, right? Density is obviously a major variable of an object in a medium that's going to determine the vector. Another very important variable is the electric field, the charge of the object, the transference or induction of the electric properties between the object and the medium. And you can get into, again, electric permittivity and magnetic permeability. The actual interaction electrically between the object and the medium is a huge deal that directly affects vector. And this is proven by simply putting an object in an electric field, then manipulating that field, or say flipping the polarity of that field, the objects will go up. That means provably the electric field is playing a direct role in the vector that object goes. Provably,
Okay, I think
objectively, indisputably. Can we all agree on that?
yeah, no one. I think no one is disagreeing that in an electric field you can levitate things because the charges are repelling and attracting each other. And it's also super easy. For example, if you have a balloon, like a helium balloon in air, and you have so much weight so that the balloon is not going up and not going down, so it's neutrally buoyant. And then you have a charged balloon on your hair, you can attract that balloon left, right, up, down. You can do everything with the balloon. That's absolutely fine. The thing is, you say that electrostatics is causing everything to go down. Like we are living and going down, but it's kind of impossible to have a, I don't know, 10 quintillion big field of electrostatics to levitate a human because it will die and it will be too dangerous. Why is it not to be dangerous just standing here while it's pulling me down?
Okay. This goes
See
back to you
again.
not understanding. Yeah. Like I'm not saying there's an immense force pulling things down. I didn't say that. So on the Earth, there's an electric field. We have equipotential lines. There is an increase in potential proportionate to distance. It's 100 volts per meter. This results in a downward electric current. It's a very nearly constant. Does that sound familiar? Very
What's
nearly
the
constant. It's very nearly constant downward
Witsit?
electric current. What's up?
Witsit? What's the name of the motor they can actually run off of this current?
Corona motor.
The Corona motor. All right. Go ahead.
Yep. It's electrostatic generator. So there's a very nearly constant downward electric current that is pretty weak in a small local scale. But when we talk about the entirety of Earth, there is a ton of downward electric pressure. Now, when say I'm standing on the ground, which was like your question, like why is it not too much for me right now? Again, it's very weak. The downward electric current. So in your little like meter or whatever, it's not a ton, right? Your little square meter is nothing. But the main thing that you have is weight. And so because you have weight, which is what gravity actually means, gravitas, heaviness, heavy, weight, because you have weight and you're more dense than the medium, you're on the ground. So when you're going to try to flip it, you don't only have to you're not only like countering or changing the downward electric bias that's very weak and very nearly constant. You're actually having to overcome an additional variable of weight, right? So you're having to overpower all of that weight to then counter it to cause it to go up. So
Austin.
now you have to ask yourself, what is the cause of weight? And that's why I always say that's what your guys' question actually is. Because when you say why down, it's why do objects have weight? Why when they have weight, do they go to the ground? Well, there's an up and down. The surface of the earth is negatively charged. The air is positively charged. We ground things at the ground. That sets the direction. And then density and or weight source everything else out. And then I'm almost done here, but weight equals mass times gravity. Mass is volume and density, and then you have gravity, little g, which is downward acceleration. That's just us quantifying how fast things fall. And density itself being the compactness of matter means that the cause of it is what's holding the matter together with a certain compactness, which is electrostatic, meaning the inherent electric variables of the matter is what's actually giving it the density, which then gives it its weight. So that is the answer. Everything's electric all the way at the foundation.
Do you think electricity causes magnetic
Came back to
fields?
the question I was trying to answer earlier, but got stomped all over. So when they asked the question, why down? What causes it to go down? What causes the medium to interact with the given object so that the object accelerates down? We can ask the same question about every other phenomena that we've ever observed, even within their own paradigm. And that question is simply touching what is sustaining the uniformity of nature. Then they roll their eyes and scoff at me like what I'm talking about is ridiculous or like I'm deflecting. No, when you ask that question, what causes the normal function of the physical entities, the creation to be what it is, it's asking about the uniformity of nature. What causes, what is sustaining the uniformity of nature? They have
Your
that
God,
same question and
your
they
God
can't answer it. And then
Your
when I
God
give the answer, they just ignore my answer.
Your God does. Do you think electricity causes magnetic fields?
No.
Oh,
I
I got
think
a question for you
electricity is the hybrid of the dielectric and the magnetic. So to say
guys.
electricity causes magnetic field is fundamentally malformed.
If you run a current through a wire, you don't think it generates a magnetic field?
I didn't say that.
I got
So what's
something right after
what's
this, but go
causing
ahead.
what's creating the magnetic field when you run a current through a wire? Is it not the electricity?
Yes, the electricity can generate a magnetic field, but the cause of magnetism is not electricity because electricity itself is the hybrid combination of the dielectric and the magnetic. So it would be pretty ridiculous to say that when the constituent parts of electricity include magnetism, you turn around and say, oh, that electricity causes magnetism or is the cause of magnetism. Doesn't make any sense, does it? Because the electricity itself that generates the magnetic field already had a magnetic component intrinsically. It's a constituent part of electricity.
I was just
But
going to
that
ask
was not
why,
what he asked.
I was just going to ask why my magnetic detector, when I go searching for control for when I'm surveying, it doesn't ring on the ground. Like why the Earth doesn't cause it to.
Are you disputing that the surface of the Earth is negatively charged?
I mean, my magnetic detector doesn't give off that charge. No.
Okay, well, it's a well-known fact. And also, we ground things with the Earth. That's why it's called grounding,
Because it's
and that's because
neutral.
the surface of the Earth is negatively charged, which actually just means just Google it. Is the surface of the Earth negatively charged? Just Google it.
Yeah,
Instead of arguing with me about
while
it.
you're googling that, when something's in free fall, what is G? While something's in free fall, the little G. What is it? Does
The
anyone know?
acceleration? You mean the
I'm an
acceleration?
ignorant ass. I should shut up and actually ask myself the question, do I know what the fuck I'm talking about?
Greg, you're hot micing.
That wasn't me. Someone is playing a recording of my voice.
Oh, guys, don't do that. When something's in free fall, what's little G for that object? Does anyone know? I'm trying to plug in W equals mg while something's in free fall, just so everyone knows what is going through my head.
I mean, would it change?
Doesn't apply. It doesn't apply.
What's
You're
little
talking about
G
the
when something's in?
acceleration?
What's little
Doesn't
G
apply.
if something's in free fall? What's little G?
I mean, isn't it just like
The
9.8
acceleration.
or?
You're saying F equals ma. You're talking about the acceleration.
I'm saying W equals mg. What's the G?
It's gravity.
Yeah, what's on a free falling object? What number am I going to put in for the G?
0 because you're counteracting gravity, so that's why it's weightless.
So there's no G is the downward acceleration. I thought.
Yeah, that's why objects are weightless in free fall.
No, but it's accelerating downwards. Why would we put zero
terminal-
there if it's accelerating downwards?
Because as long as you're not in air, I mean, if you're in air and you reach your equilibrium, like the resistance, like a skydiver,
terminal velocity.
yeah. And if you're
oh, I thought you were done. Go ahead.
Sorry, no. If I would say if you're in a vacuum, like if you have a high tower and that's, let's say, nearly no air in it, and you fall down, then once you are accelerating with 9.8 meters per second square, then the 9.8 meters per second square are zero in your point of reference. So
just, oh, you're still going? Go ahead. My bad.
Go ahead. No, go ahead.
So we're saying that when something's free falling, it's not accelerating? It would be a zero there because there's zero acceleration.
No, if something is free falling, it is accelerating. So the whole object, everything within the object is accelerating with 9.8 meters per second square.
Yep. So when we got W equals mg and I'm about to fill in the g spot, it's definitely accelerating. So what I put a positive integer there, right? Like what number would I put there?
Would it not just be 9.8?
What's up?
So for G,
they won't do it, Armbar, because it's about to debunk the whole thing.
I mean, if it's falling, I mean, I guess like whether it's falling or not, wouldn't it always be 9.8 unless like you're talking like relatively speaking, like if two people are falling, then maybe relative to each other, that's like no longer, that I don't know.
Debunk their whole thing with me, Armbar. Let's go.
I don't know how it works, frankly. I'm just sort of,
No, but that's exactly the point. So your mass is accelerating with g with 9.8 meters per second. So while you are free falling, while there's nothing pushing against that free fall, g would be zero. That's why you are weightless. So with the w is equals mass times gravity. So the weight is equals mass times gravity. That's what you want to say. That would be then zero. So the weight is zero. The mass is still there. The acceleration is also there from the outside view, but you cannot measure it in that frame of reference.
Yeah. Hold on, man. Hold on a second. You're not ready for the W yet. We're still on the G part. We got to figure out what the G is. So we've got this thing that's accelerating down at 9.8 meters per second. Yeah. What do you usually put in for the G number?
At 9.8 meters
let's say something's just still on the ground. What would you put in?
No, the point is, if you let something fall, the weight does not change itself. So the weight of the object from the outside point of view does not change.
Did you hear the question I asked? Or?
Yeah, the G is still 9.8 meters per second. So the mass times the gravity, then you still have the weight. But in the frame of reference, it feels weightless. Because if you're in the frame of reference, then there is no G anymore because you are already using that.
Or can we just focus on the G for now? You keep trying to skip ahead to the W, and I'm not sure.
I said G from the outside viewing, G is 9.8 meters per second square.
Yeah. So when we're always looking at it from the outside. If we look at something sitting there or something free falling, we're looking at it from the outside. So I don't know why you would even say that. It's the same frame of reference every time. But anyways,
no, because if you're for example in a 0 Z.
Hold on, man. Hold on a second. You're telling me that when we drop something and it's free falling, we're gonna put in G as zero, even though it is accelerating. And normally you would put 9.8 meters per second squared in that number spot for G.
No, I say if you, for example, want to know the weight of something, let's say we are in a parabolic flight, a 0G plane, and in that weight is not or this formula does not say an absolute value. It does not tell you an absolute value. It's always a relative value.
Just stop with the weight, bro. We're just trying to figure out what the G is.
Yeah, but you
keep skipping to the W. This is like the third time I've told you, please stop trying to skip to the W. You got to figure out the G first.
Okay. The mass is clear. The G is 9.8 meters per second square. Now let's put it in the formula. W is equals m times G. So then the question is, from where are you looking?
That was from the free falling object? Hold
Yeah.
on. So that was for the free falling object. We're going to put in 9.8. That's what you would put in.
Yes.
And then the mass, obviously, whatever the mass is. And then
Yes.
that would equal a weight. And then free falling objects, they would have that much weight,
Yes.
right? 'Cause
1 kilo, 1 kilogram,
W equals mg works, right?
1 kilogram mass in a free fall still weighs roughly 1 kilogram on Earth. Yeah.
No, but it has no weight at that moment.
No,
The
that's
weight
not
is
true.
zero.
It has still this. No, it has still the same weight.
No,
And
free falling objects.
no,
And
a free falling object has still the same weight because if it hits the ground, that impulse is still hitting the ground with exactly that weight.
that's just not true. A free falling objects have zero weight.
No,
I don't know
that's not true.
why you think it. Well,
If you catch it, it's pretty heavy.
I'm gonna go. We'll Google it right now. Hold on. I mean, I think it does have weight. I don't think the shit magically loses its weight. But the mainstream paradigm, I didn't know you weren't with the mainstream paradigm. That's cool.
I thought that's like a reference. I don't want to say reference frame, but like like a kind of like a reference frame thing. Isn't it like depending on like what you're talking about? Like if I'm falling with something, then I guess relative to me, that thing is weightless, right?
Correct.
But yeah, so isn't that like a reference frame thing? I guess in a way.
Yes,
I don't know.
that's why in a zero, I'm not losing weight if I'm a parabolic flight. The point is just the acceleration of the reference frame is canceling out my acceleration down to Earth. So it feels weightless because you are accelerating with exactly that acceleration that is acting on you.
Right. So I guess depending on the reference frame, you would either put 9.8 or 0. Then is
yes. So in that reference frame, if the reference frame is accelerating with you, and there's nothing acting against that acceleration, you put in 0. So in a zero G bomber, that's not in a free fall. It's going upwards, and once it's pushing its nose down, you already feel the weightlessness. So the felt weightlessness, because then your acceleration or your trajectory upwards is then getting slower and slower due to whatever pulls you down.
Yeah. All right, man. We're saying free fall objects have weight. Yo, Witsit, you still there?
No, he headed out.
What's up?
He headed out.
He's out.
Oh, damn! I wanted to talk to him about the Horizon thing. Really? Come on.
He ran away again.
Probably he heard Armbar and was like, "Yo," he didn't want that smoke.
Scared of Armbar. The troll in training, or not troll, Glober in training.
Because Witsit, Armbar, did you redo that little
The model.
That little thing you made? Yeah.
I mean, I made one with the baller to show like like ball like
Can you
spheres.
redo the same one? Can you redo the same one and just add a horizon in, like make it a different color and just add a horizon in so you can see exactly what's going on? Because that was good. The thing you did was good, but you just didn't have just add a horizon into that so you'll see it going up. It'll be going up.
Well, hold on. When you say add a horizon, are you telling me to add like a flat like plane in that model, just a flat plane, like a really large flat plane?
You're down at the bottom. You're down at the bottom, right? Where you start off. Then you rise up.
Uh-huh.
As you rise up, have it do what the horizon does.
But there is a horizon in there, the edge of the table in that model. That's
not how horizons work, though. That's not how a horizon works.
Well, no, forget about the purple ball. Look at the rest of the balls. Look at the red, yellow, green, and blue ball, or teal ball, right?
Can you maybe post it somewhere here so that we all can participate?
Yeah,
Post it in the thing. All you need to do is just add an actual horizon into that, and and every time you do it, put a ball on it so we can see the ball going up.
So you want me to do a ball Earth instead?
No, bro. Yeah, whatever. Make it a globe. I don't care. But do the balls like you did. Do those same color balls and then add a new color on, and have it do what the horizon does.
But this kind of does what the Horizon does a little. Not obviously 1-to-1, but it does.
It doesn't do what the Horizon does, bro. You have just a static spot. The reason the Horizon does that is because it extends out as you go up. You have a static position there with all those balls. They're all static. There's no balls that are getting farther out as you go up. That's where you see. That's how the effect happens.
Okay, I'll do it better then. All right, because I mean it's essentially the same thing, but I'll do it better. That way you're happy, with it. Because
Not better. Just do it right.
it is right.
Just do it right, bro. We're talking about the Horizon. You didn't use the Horizon.
I used the table. Oh my god! You know what? Hold on.
That's not a Horizon. That's not how Horizons don't work. Like the edge of a table as you go up.
Do you mean like the table should be extended further behind this? I don't know. Is it blue or ball? So it should be infinite.
We're having a discussion about the Horizon, just what we see on Earth.
But I see this video with these half balls that are kind of in the surface, or semi spheres that are on top of the table and then lifting up the viewpoint, right?
Yes, but what he needs to do is add another colored ball. Except as he goes up, do what the Horizon does. See farther out.
Yeah, but that means like the at the moment the table has an end. Where the blue ball is, the table ends, right? This is not reality. There is no end, right?
What's more purple?
So he just needs to add a Horizon in as we see it on Earth. That's all.
It's close to purple, but it's close to blue, but whatever, close enough.
I have color issues, so for me, blue, purple are all the same. I don't know.
Yo, Armbar, keep that same exact thing, and just add another colored ball, and like scale it for what happens on Earth.
So you mean the ball should move to the back, or what?
Yeah, like if you're on the surface, when he's down at the surface, scale it out for a 6-foot observer, 3 miles. As you go up 7 feet, move the ball out a little bit. You know what I'm saying? Extend the horizon, because now you can see farther on Earth, and just keep doing that as you go up.
Okay, so you mean the purple ball that should be then on the horizon, that should go further away, because you see more when you go higher.
No, I want him to keep all the balls and add a new color ball, because I like how that setup is. He just needs to add a horizon as we see it. You're at 6-foot observer, you see 3 miles. You go up to 7 feet, you see 4. Whatever the ratio is and how it happens, just put the ball, keep extending the ball out farther in that ratio. Is that like perspective mode? I mean, was that even Blender?
Yeah, that's Blender.
You got perspective mode on and all that. Like, don't play any funny games with funny business.
There only is
bro. I'll smell something fishy a mile away with you.
There's only perspective. I mean, unless you're doing some weird rendering where you could do like orthographic mode or something, but like that's.
Don't do anything weird, bro. Don't.
I'm not.
Find out it does what I say and then try to like start tweaking it around and shit, so to make it look not do what I'm saying.
I'm not even sure what you're talking about.
You know what I'm talking about.
I don't. I'm trying to figure out because I already showed there's the edge of the table is supposed to be the horizon. The whole point was that if you look at the balls and then you look at the edge of the table rises above those balls. That was the point of my animation, but I feel like you're overcomplicating it. I don't know.
Bro, we're talking about the horizon. Your shit doesn't have anything that's doing what a horizon does in it. Why would you think this is even close to being complete? You're missing the whole. That's the whole kit and caboodle right there.
I think the only thing that I see in the animation that is kind of not as in reality, that table has a limited distance to the back, so it's only, I don't know, 5 feet long or so. So if it would be infinite, then the horizon would not.
Nothing's infinite. Nothing's infinite. We got the horizon. There's no infinity in this thing at all.
Right. I mean, I actually zoom out and then I show you that there's literally like a whole ass table. But or at least a surface. All right, but like Jeremy,
Yo, I
I'm
like that.
genuinely-
That was good stuff, bro. I'm gonna give you a B+ for effort right there. If you just add the horizon, and I can up your grade.
I don't even know
And I'll have to see you after class.
Well, you.
I also don't get it. I don't get it.
Look, Jeremy, I'm really confused right now because I'm
You
gonna
don't get
record
it?
Jeremy, look, I'm gonna record it again. All right, I'm gonna move. I made the balls a little smaller, but I'm gonna show you like what the point of the video was in the first place, though. So
Yeah, the point was the point was that you're trying to say that the thing I'm saying isn't true, and this animation was supposed to show that, but the thing I'm saying has a horizon in it, and you don't have anything that's acting like a horizon in that.
let me see.
So
Well, hold on,
obviously,
you-
But
you're missing
I
like
think the
whole-
horizon.
you don't
But the
think that you-
horizon is the line where the table separates from the heaven,
yeah,
isn't
the
it?
gray sky. I mean, I'm confused. I mean,
Yeah.
like, you really mean to tell me this doesn't act similar to a horizon? Like this, what I
No,
have
dude.
here?
As we go higher, the horizon extends. We see farther.
Yeah. Can you look to the second
That
video?
is
He just
not.
posted a new video.
Oh, you did a new one? Okay, let me see it.
Well, and this one, I mean, all I did was get rid of the purple ball. Basically, I made the other one smaller. But my point was because you said,
So you still don't have the thing in it with the horizon.
look, but in your DM, you literally said what the reason why it's rising is because you have a mountain and you have the horizon, and then the horizon will appear higher than the mountain, right? Now, if we count these balls as mountains, right, then we would have the horizon higher than the mountain. So at least according to that strict line that you said, right? That's what you said then and there. This this checks that box. You know what I'm saying? The horizon is higher than these balls or higher than these pseudo mountains. So I was just trying to cover that, because I was like, that doesn't make any sense just because
I
it's higher.
understand how that works. The farther away it is, the slower it'll fall. Obviously, I understand that. My thing is with the horizon, so you got to put something in there that mimics the horizon. Like I said, you're at 6 feet, you see 3 miles. You go to 7 feet, you can see 3.5 miles. You go to 8 feet, you see 4 miles. Like extend it out like that.
Okay, but the only way I could do that is one or two things, right? One, I have literally a ball Earth, or two, some weird refraction thing, which Blender, you can kind of pull off with
Make it a ball. Make it a ball Earth. That's fine. I don't care what you do. We got to have something in there that mimics the horizon. So,
all right. I actually have a ball Earth version of it, so I can do that. I can literally just record this real fast. Just give me 1 second. I'm gonna change the sizes of the balls, make them, so they're not that big and
get some big balls. Get some big balls in there.
Yeah, ridiculous. All right. Anyway, here we go. So I'm gonna record this. Time, bro. It don't make no sense, man. Here. Oh, hold on. Here, I'm gonna record this right now. Okay. Get the green one, and then eventually the blue one in the back. Okay, there we go. So here we go. I'm gonna send it to the chat now. This is count as spam. My video folder will just load up faster. But like my thing, here's my thing, Jeremy. Right? Like it still doesn't make you still don't have a good argument though. Like even if your argument is that we're seeing further or something, or whatever, right? Therefore it counts as rising. I think that's a weird definition for rising. I don't think that counts as a horizon that's rising. That doesn't really make any sense to me. But here, I sent the video. Check it out. You're rising. You're seeing the red ball, then the yellow ball, then the green ball, and then off in the distance, very far away. It's kind of hard to see, but there's a blue ball. You see it? Hello? Jeremy? Excuse me. Does anyone see it? The video I sent?
Yeah, I can see it.
Yeah, so I don't think the reason why I don't think it counts as rising is because like it's just you literally just if you take out the ball, right? If you take out the ball and you just leave those points, those red, yellow, green, and blue balls, right? What you would see is that the blue ball was already the lowest, right? Like if you could see through the Earth, the blue ball was the lowest. It's just that it also has the smallest amount of parallax. So as you go up, right, the other balls are going to fall faster, and in fact, they're going to fall fast enough to where eventually they fall below the blue ball, basically. And as you keep rising up more and more, you'll see more and more balls, and those will drop slower and slower as well. So the ones in front are just going to drop faster. So it's not so much that the horizon is rising; it's just dropping slower and slower and slower. Because of parallax, and until it completely drops out of your view. And I don't know where the fuck Jeremy went. I mean, I literally I took like a minute.
He's still muted. He's no.
I took
Jeremy?
1 minute to record it. It wasn't that long.
Let me explain this to you.
Wait, look at the video. Look at the video. Look at the video.
Perspective. Just hold on. In perspective, the sea. If you're looking out at the ocean, the sea appears to rise towards your eye level, right?
Approaches. It does get lower.
It approaches your eye level, but we know it's under your feet, so we know it's not even close to being where we see it. You know what I'm saying? It's actually under our feet, but perspective makes it rise up to be at near our eye level. Right?
Same thing for the edge of the table, though. That's
just
why.
Hold on. Just hold on. Just follow. Let me lead you through this real quick. This is going to be much easier if you just hold my hand.
God.
All right.
Hold my hand.
We know that happens, right? Like things are really way lower, but they appear to rise towards your eye level, right?
Okay.
In perspective, is that correct?
Yeah, because the angles, yeah.
Yes. Okay. So where the horizon was at one point is going to be you're going to see farther. So that farther part is going to rise up towards your eye level, and the horizon you saw before is going to be way lower. You see what I'm saying?
Well, that's the thing. You're wrong about that. At least if we're going off of my little model here, because as you can see, it's not so much that the orange ball rose; it's just that the red ball lowered below it. That's it.
Man, what was wrong about what I said?
Because you're making it seem like the new horizon is sort of replacing the old horizon's position, like it's at the same height, and that the old horizon is just lowered. But no, it's all dropping. It's all dropping. Just the newer horizon is just dropping even slower, and the newer one is going to drop even slower than that one, and it's going to keep on dropping slower and slower and slower and slower because of parallax.
No, but we agree it always appears to rise up towards your eye level. Like the purple ball, it doesn't do that.
I would actually
disagree. It doesn't do that because it's not getting farther away. It's not getting farther away. With the horizon, it's getting farther away every time. So your old horizon is now in the middle of
so you want
beneath you into the new horizon.
Okay.
So you want to have
rises up
you want
towards
to
hold on.
Sorry.
Man. And the new horizon is now rising up towards your eye level. It's almost near your eye level, a little bit lower, whatever. But it's keeps coming up towards your eye level. That purple ball doesn't do that. None of those balls do that because they're static. They're not going farther out each time.
So you want to have a ball that is moving where the apparent horizon is all the time. So you want to see a ball as a marker at the apparent horizon.
You don't need a visual for this. The thing I just said is true. That's how it happens. The horizon always rises towards your eye level.
Okay, and that was something that I wanted to react on. That's actually not true, and that's also Witsit said that on the travel to Antarctica it rose to eye level, but that's not true. I mean, we humans are super bad in eyeballing what is on eye level and what not. But I mean, it's really measurable. Like if you are in a plane on travel altitude and you have good weather and you have a sharp horizon, you can really measure that it's way lower.
I know. That's why I said toward eye level, not at eye level.
I would say
sometimes it's above. Sometimes
level.
it's actually above. Sometimes it's actually above eye level. Jesse's actually measured it above eye level. That's not the point, though. The point is it rides
but that
towards
can
your
only
eye
be
level. Yes,
topography,
a
right?
little bit lower. Yes, it's a little bit lower, but it rises towards your eye level all the time. So when you go up from if you're 5 feet high, it's almost near your eye level. If you go to 40,000 feet high, it's still almost near your eye level.
Can we just real fast? Can you watch my video 53 minutes past the hour? So you can at least tell me whether or not I did it right in that one, because I don't think you watched. Yeah, 53 minutes past the hour. Because I have a feeling you're going to say I didn't do it right because the horizon is dropping a considerable amount, but yeah.
I'm watching it. I don't. The horizon's dropping way too fast. How high are you? How high are you there, and how far out is the horizon? It's in miles, or do you have any kind of measurements going here?
Not really, but I imagine it's like you're probably already really high up, and you're also probably traveling you're probably traveling like a couple of miles as you're moving up. So imagine you're dealing with like really like large like mountains that you're looking at in this thing here. I mean, I can get closer to reality where it's like like at least if we're assuming a ball Earth, right? I can make it where we're like really really tiny, and then only moving up maybe like a mile or two. I could try that, but
No, scale it up. Scale it up, bro. From 6 foot observer, 3 miles. Scale the shit all the way up.
Okay, I don't know if I can go
Go
that far.
to I don't know. I don't know how we even need a diagram or an animation of this though, because what I'm saying is true. The horizon rises towards your eye level, no matter how high you go. Right, 50,000 feet, it's rising towards your eye level. Right.
Look, fine. I'll try the 6. I'll try as best as I can, to do a really large ball, but it's not gonna be easy though. Just so you know, this is gonna be pretty tricky because the scales are gonna get kind of insane.
You don't even have to have a ball. You just need an object and scale it at the appropriate distance for the appropriate height. Like, I don't know why you think you need a ball for this. You can use a ball, I guess. I don't know, bro. If you're at the ground, say you dig a hole in the ground and you put the horizon exactly at your eye level, right? You get the horizon exactly at your eye level. That piece of the ground is way beneath you. If you go up for 50,000 feet, that piece of the ground is almost directly underneath you now. However, the new horizon is still rising towards your eye level, right?
Yeah, give or take.
Yeah. That's what I'm saying. It's rising with you, but
I wouldn't say
like,
it's rising.
how
That's colloquial talk though, because it's not really rising though. Like
it's not actually rising. It's apparently rising. I know.
Yeah, but I would
Because
say
perspective.
But I would even say if the frickin' table was like what? So what? The difference
Nope, the
between
table wasn't rising because it was a static position. You didn't extend the vision out like it does when we're on Earth.
So that's the difference then? The difference is whether or not it extends, like you see more and more. That's what makes it rising. It doesn't make any. It's a really weird
That's
definition for
what
rising.
causes it. I think that's what causes it to appear to rise. That and perspective, the way perspective works. You're seeing farther. Perspective's a thing. The horizon, always rises towards your eye level, very close to your eye level, and that means as you go up 50,000 feet, you're seeing more land. It's still it's still near your eye level. Like it rose with you. I don't know. It's pretty.
Yeah, but okay, but when Ruhif says that it's dropping, right? I mean, it is objectively dropping, though. I mean, it's just because he's saying it's not. You're saying, relatively, speaking, yeah, it's like
Bro,
it's
it's
rising.
dropping. It's dropping. Of course, it's dropping.
So then
It's
why do you want
actually
to?
dropping. It appears to rise with your eye level, though.
Yeah, appearing and actually in an objective, it's something objectively
Of
doing
course,
something.
it's dropping. It's the
So
ground.
then why do you want to like give this to Ruha for something as if he doesn't understand? Like
He doesn't. So you agree with me? It does appear to rise it does appear to rise with you as you raise in altitude.
I mean, to some extent, because I would say the freaking table does, but you said it doesn't. So I mean,
The table doesn't. The table objectively doesn't rise with eye level. It's just lowering. It's not getting any higher at all.
If I had a bigger table though, or if I lowered
a table, dude, a table is not what you need. You need something that acts like the horizon, acts like we see it on Earth.
You're something else, man.
Use your head. Stop hanging out with Ruhif.
I don't even hang out with him. You just don't make.
He's
any
a bad
sense.
influence. He's a bad influence.
You don't make no sense, man. You don't make no sense.
But the thing I'm saying about perspective and the horizon.
Yeah, you make no sense.
Which part didn't make sense, Armbar?
It's like you're contradicting yourself. It's like you're contradicting yourself because, like, if I was to do like a really big table, right, you wouldn't even notice the freaking table was dropping. You'd be like, "Oh shoot," it would appear that's rising. So it's like, you want me to do a big table right now? I could do like a really big table, And it
Armbar, you need help, bro. This ain't about a table, dude. If you make the table extend as you go up accordingly to what the globe does, then go ahead. Just a static position on a table, though, is not what the horizon. That's not how it works. You're not mimicking it at all.
I think he's saying if you made a really big static table, it'd be the same thing that you're saying.
it would appear very similar.
No, it wouldn't appear very similar. It wouldn't appear anything at all like it because it's not doing anything like what the horizon does. You're not seeing farther as you go up.
Okay, even if you don't see farther as you go up, seeing farther once again, that does. I don't get how that makes it suddenly like a rising horizon. Like how is that the defining fact, like the defining thing? Like how does that if you don't see farther, okay, now it's suddenly not rising. But if you do see farther, now it's rising. Like how does that even compute?
Yes, if you don't see farther, like all your balls on your table, if you don't see farther, they just drop. That's all they do is they just drop. Depending on distance, they might drop slower, some might drop faster, depends on the distance. However, when you have a position that moves like the horizon does when you see farther, perspective will make it always rise to eye level, thus rising with you. Like perspective, when you see farther and that static thing gets closer to you on the ground, it's just going down. It just appears to be just going down. The horizon appears to be rising with you because the shit always rises to close to your eye level. I don't know
I
how
get what you're
hard
saying, Jeremy.
this
I
is.
think you're wording it wrong, though.
The horizon appears to rise to your eye level. The horizon appears to rise with you as you rise in altitude. That is my final answer.
So it has nothing to do with being static.
Yeah, the horizon's not just a point on the ground. It extends as you go up. The Armbar's thing has not it was a cool little thing he showed that things drop slower if they're farther away because that's how that works. But as far as the thing we're talking about with the horizon, I mean, I don't even know what's in contention. Does the horizon always rise towards your eye level?
It just lowers.
It has a slight drop over time.
Yes, it doesn't rise with you perfectly in the same ratio, but it does rise with you. It rises less than you do, slightly.
It doesn't make no.
Well, I think it's weird because, like he was saying, you're using these terms where you're saying rising and using the word static when in reality both examples the ground is static, but you want to say it's rising, so it's just weird.
I'm talking about static front to back. Like the horizon, you're not with his spheres. Say one of the spheres was 6 miles away. It's always 6 miles away. The horizon is not always 6 miles away. Every time you go up, it's going to be 7 miles, 8 miles, 20 miles, 100,000 miles, whatever, however far the horizon can get. You know what I'm saying? So that's why. That's why it needs to act like the horizon does. Those spheres don't act like the horizon does. They're static.
Yeah, but when you're talking about the ball, you're talking about a static position object, and then when you're talking about the horizon, if I was to keep my finger on the point on the horizon I'm looking at and then go up, that point of the horizon is also static. It's just you're seeing past it now.
Okay, when I say static, I'm talking about the distance. The ball's distance on the table, the balls are static. They're distance. They're not changing. The horizon, not static. The distance is changing.
Yeah, but the point of the initial horizon, right before you rise, that isn't actually extending. It's a new horizon you're looking at.
Yeah, it's a new horizon, fine. And it's rising with you it's appearing to rise with you as you rise in altitude. The horizon. This ain't hard. If you guys didn't fight us all the time on perspective,
No, it's not
this
rising.
would be we would have breezed past this like 3 days ago.
No. You just
Yeah, yes.
you're saying some weird shit, man. All right, let me show you right
Not
now.
saying anything. What's weird that I said, bro? I'm just saying exactly what happens, how perspective works, what we see.
Because your definition for rising is just it's very contradictory or just very it's not like
What's my definition for horizon? I didn't
don't know,
even
you
tell
gave
you it.
well no not for rising for rising for not normal. Remember, because in our chat, right, you were saying, oh, the horizon doesn't rise normally or whatever, right? Or you basically saying it rises, right? So you for something to rise, right? You gave like a bunch of like explanations, like the
Dope
whole,
ass answers, I think, is the word you were looking for.
no, look, I'll read them out right now, all right? I'll read out your. Doesn't make any sense, all right? You said, hold on, give me a second if I can find it.
Forget what I said in DMs, bro. What about what I said just now was weird or wrong? The horizon always rises towards your eye level. That's correct, right?
I mean, I don't. That doesn't make any sense. If I have a really long ass table and you rise like 10 feet off of it, right? It's the horizon, the table, the edge of the table is still going to look like it's still going to be at like, near eye level. I mean,
Oh man, you're hurting my brain, bro. The edge of
okay,
the table is not doing what the horizon does. It's a static, fixed distance. The horizon is not.
okay, I get that,
You're
but
hurting my brain, Armbar.
I
I'm
get
about
that.
to
I get
piss
that.
you.
Hold on. I get that. I get that. It doesn't do what the horizon does, but doing what the horizon doesn't make a thing rise or not. That's what I'm trying to get at. Like your definition for whether for whether a thing rises or not is just really weird. Like I don't get why the horizon, why it has, why it extending is what makes it rise. So like if it doesn't extend, it doesn't rise all of a sudden. Even if it's still at the same dip, even if it has the exact same dip angle, right? You would argue that no, it's not rising or something like that. Like I just find that really weird. Like I don't know.
Bro,
It's
let's
just
pretend we were on an infinite plane with no atmosphere. The horizon would be exactly at your horizontal, right?
yeah.
Yeah. Then as you went up, where would your horizon be? Say you went up 100,000 feet, where would your horizon be?
Still be at eye level.
Holy shit. Would you say that it rose with you as you went up?
In that case, I mean probably because in that case it's actually like at eye level always.
Okay,
Infinite.
what if there was all right, what if there was a little bit of refraction and when we started it was slightly below your eye level, but as we went up, whatever refractive effects happened, it made it drop slightly. So now we're at 1,000,000 miles high and the horizon's a tenth of a degree under you. Would you
Wait,
say it rose? Would you say it rose with you then? It appeared to rise with you then?
what was it? What was it before angle? What was it before?
It was 100th of a degree. Now it's a tenth of a degrry.
Then I would
Would
say
you say it rose with you though?
no, because it clearly dropped about 99. Well, it dropped. What was it? Hundredth? Wait, it was hundredth of a degree. Then tenth
Oh
of a
my god, it
degree.
went from 100th of a degree to 200th of a degree.
Wait, that means it.
Would you
Wait,
say it rose with you?
well, at that point, yeah, because it went up. You said 100th of a degree drop versus a 200th of a degree. So that means it actually there's a smaller angle now. So in that case, it actually went above where it was.
Dude, it dropped one. It was under 100th of a degree. Then it dropped another 100th of a degree
Oh
when
no,
we're up.
then it dropped. Yeah, then it dropped.
So it didn't rise with you, even though it's almost right at your eye level still.
No, because at that point
And you went up 1,000,000 miles.
yeah, because at that point it's like the parallax arguments I keep giving you, where it's like you drive past the mountain takes a really long time to leave your view, but it is technically moving. It's just, but you would say, oh, the mountain is sort of following me. You know what I'm saying? Like it's not really following you, but you could say it colloquially.
All right, man. All right, I don't know what to tell you, bro.
I don't know either, man. You're freaking something else. I'm still working on this model.
I mean,
by the way.
does anyone else think? Am I tripping? Am I the only one that thinks the horizon rises with you?
Yeah, you're tripping multicolored balls like in
It
my
appears
animation.
the horizon. Here's the exact statement: the horizon appears to rise with you as you rise in altitude. I feel like that's a safe statement. I don't know.
Colloquially, I would agree. Colloquially speaking, but objectively, it is dropping. Here we go. There we go.
Colloquially, it really appears to be rising with you.
Well, then the mountain really appears to be following you.
Nope.
See,
No,
this
it
is why
doesn't.
I can't. This is why I can't get. Like, I don't get you. Like, your logic is like, it breaks up at certain points. Like, what is this? A mountain does appear to follow you. You know, it's like you can't even say consistent, man. This is weird.
Yo, driving by a mountain is not analogous to this. Like, I don't think at all.
Right, because the difference is that the horizon extends to more land, but that doesn't make any sense. That's irrelevant to rising or not. That's stupid.
You're seeing farther, so now the horizon's still almost at your eye level. You've raised up 100,000 feet. Horizon's still almost at your eye level. This ain't hard,
I'm
bro.
checking on Austin. Is he all right?
What's up?
What's up, guys?
Who are you?
Ready Player One.
Oh shit, that's you. Ready Player One, huh? That's your name. Like you're the Ready Player One.
Hey, I'm just checking up on Austin. Is he all right? Where'd he go?
I don't know, but
I got him locked in my basement right now. You can't talk to him.
there you go.
I logged in and he logged out.
You could join, but you'd have to be locked up as well. So I don't know if you want that.